Chapter 11, Magnetic Material. Now, today we discuss magnetization and magnetic intensity. The magnetization given letter capital M and magnetic intensity given letter capital H. First we discuss about magnetization. What is called the magnetization? In previous lecture we study about the magnetic field, magnetic length, magnetic dipole moment. Then what is meant by magnetization? Magnetization is nothing but the ratio of two quantities. The first quantity is net magnetic moment or magnetic dipole moment to its volume of the material. It is nothing but magnetization. Definition is very simple. Magnetization is nothing but the ratio of magnetic net magnetic moment to the volume of the material. Volume of the material is called magnetization. Is called magnetization. The ratio of magnetic moment or net magnetic moment to volume of the given material. That is, M is equal to M small m net, that is net magnetic moment divided by volume. Therefore, SI unit is ampere per meter or ampere inverse, and dimension L minus 1, M0, T0, I1. This is the dimension of magnetization. This is about the magnetization. The magnetization is nothing but the magnetic net magnetic moment. It is the ratio of net magnetic moment to the volume of material. This is the formula. M is equal to M net divided by volume. SI unit ampere per meter, and this is the dimension L raised to minus 1, M raised to 0, T raised to 0, I raised to plus 1 or 1. Now we consider a rod. We consider a rod, and this rod is kept. We consider a rod of magnetic material or such material. This rod is Consider a rod of magnetic material or such material, and this is kept or placed in solenoid. This solenoid with n number of turns, and also carrying current I, and carrying current I. This solenoid having n number of turns and carrying current I, and such a rod made from magnetic material is placed in solenoid. Solenoid कसा आहे? Having n number of turns and carrying current I. Then we find out the magnetic length inside the solenoid. Magnetic field inside the solenoid. Or this, in case of solenoid, we already proved solenoid and toroid how much magnetic field is produced. In case of toroid, is suppose B0 is equal to mu 0 n I. This is the magnetic field inside the toroid. Also, suppose let Bm with the magnetic field inside the solenoid. Magnetic field inside the solenoid. Therefore, total or net magnetic field will be B, and this is equal to B0 plus Bm. And this is called the net magnetic field or net magnetic magnetization. B is equal to B0 plus Bm. Also, it is observed that the magnetization Bm, that is magnetic field inside the solenoid, this Bm is directly proportional to magnetization. Directly proportional to magnetization, or therefore Bm is equal to some constant mu 0 into m, where this mu 0, the constant mu 0 is called permeability of free space. The constant mu 0 is called permeability of free space. This Bm is equal to mu 0 m. Now, using these two equations, B0 is equal to mu 0 ni and Bm is equal to mu 0 m, then this total B will be mu 0 ni plus mu 0 m. Therefore, B is equal to mu 0 into bracket ni plus m. But n into R, that is n means number of turn, I means electric current, this product or this multiplication number of turn and current is called strength of magnetization or strength of magnetic field. and this strength of magnetic field is expressed in terms of quantity, and that quantity is called magnetic intensity. It is second topic. This term is called magnetic intensity. Therefore, we rearrange the equation, given equation, that is this B is equal to mu 0 into bracket, instead of N I will put H plus M, where H is nothing but magnetic intensity, where H is called magnetic intensity. The SI unit and dimension is same as magnetization M, because the magnetization and magnetic intensity is similar quantities or same quantities. The definition of that magnetic intensity is very simple. The strength of magnetic field at a point can be given in terms of vector quantity, or that vector quantity is called magnetic intensity, and this magnetic intensity is given as H. The SI unit and dimension is same. SI unit is ampere per meter and dimension is L raised to -1 T0, M0 T0 I raised to 1. The dimension and SI unit of magnetization and magnetic intensity is same. Now, then we find out the value of H from this equation. Above equation, mu is B is equal to mu 0, H into bracket H plus M. Then we find out H is equal to, the value of H is mu 0 upon B minus M. Using this equation, we find out the value of H is equal to mu 0 upon B minus M, where this H is called magnetic intensity, mu 0 permeability of free space, B magnetic field, and M means magnetization. From this equation, mu 0 is constant, B is also constant. This H is directly proportional to M, or M is directly proportional to H. Therefore, M is equal to, from this, M is equal to constant psi into H, where this psi, which is symbol called psi, is called magnetic. It's called magnetic. It's called magnetic susceptibility. Magnetic susceptibility, and this notation or this symbol is called psi. The relation between M and H is directly proportional, hence M is equal to psi into H, where M is called magnetization, H is magnetic intensity. Now we find out the value of psi from this equation. That psi is equal to M upon H, that is ratio psi has no unit and no dimension. No unit and no dimension. That is, psi is unitless and dimensionless quantity. Or value of psi we find out m upon h. M and h having dimension and unit same cancel to each other, hence the psi is constant or dimensionless quantity. Now from above equations you can write B is equal to mu 0 into bracket h plus the value of m, that is psi h. Therefore B is equal to mu 0 1 plus psi into h, or B is equal to mu 0 mu r into h, where mu r is equal to 1 plus psi. Also B is equal to mu h. This mu is equal to mu 0 into mu r. And again this mu r, mu is constant and that mu is called magnetic permeability. This mu is called magnetic permeability. And this value of again this mu, using this, mu is equal to mu 0 into bracket 1 plus psi. This is the different relations or different formulae in between magnetic field, magnetic intensity, magnetization, permeability of free space, and susceptibility psi. Or in this is magnetic field, constant, and magnetic intensity. This is about the magnetization and magnetic intensity. The magnetization and magnetic intensity have dimension and unit same, that is these two are same quantities. Thank you.